So I'm going to try to cover probably too much. That's my usual mistake. I try to cover too much. But I want, there's an important reason to try to give this kind of the scope and some depth. And and I said this talk is going to be about agencies of art and audience, and so I want to kind of go through this a bit of a history of what I do and why I do it, and some of the kind of framing questions that it's leading to. And as Don said, I'm an artist. I work across lots of different forms and mediums, but underlying that, there's always it's always been computation as an agency of creation, and as an agency that establishes this relationship between art and the audience. And now, one of the recent things that I've done is started this Arthur C. Clarke Center for Human Imagination, which is partially located here in Cal IT 2 and partially over at the SME building. And so I want to just talk a little bit about this idea about imagination as one of these kinds of agents between art and audience. And so the mission of the Clarke Center is to understand, enhance, and enact human imagination. It's no small task, very kind of grandiose vision, because first of all, we may want to ask a question about what is imagination itself. And so imagination is it's like a popular word. It's not necessarily a scientific word. It might mean a million different things. In fact, it probably means maybe not a million different things, but at least a dozen different things, depending on what scales you might ask about what the phenomena of imagination is, both in terms of scale of activity from neurons to brains to societies to the time frames of imagination. Does imagination shape what you're expecting to hear me say in the very next word as you anticipated and imagined? So imagination is a kind of, might be a basis of human connection and empathy. Or imagination might be a way in which we think about what might be the effects of pouring tons of carbon dioxide into the atmosphere. What kind of world might that create in 100 years? So imagination can operate in the instant and in the millennial timescales. And a lot of kind of interesting, smart people, kind of tout, say kind of interesting, inspiring things about imagination. Einstein, says imagination is more important than knowledge, and that it's everything. It's a preview of life's coming attractions, and that logic gets you from A to Z, but imagination gets you everywhere. And so that's nice. Einstein, thinks a lot about imagination, but he doesn't actually help us figure out what it is. So we still don't know anything more about imagination from these, except that it's an inspiring idea. The educator Maria Montessori talks about imagination, that it doesn't become great until human beings, given the courage and strength, use it to create. So it's maybe now a little more kind of a differentiation between imagination and creativity. The scientist Carl Sagan gives us another inspiring motto of imagination will carry us to worlds that never were, but without it we go nowhere. And I like this quote from Mark Twain, and you'll understand more in a moment, that you can't depend on your eyes when your imagination is out of focus. So there's now some kind of, I think, a bit of a cognitive phenomena being described here that Oliver Sacks takes a little bit further to actually now start to describe something a little deeper about what imagination might be. That every act of perception is to some degree an act of creation, and every act of memory is to some degree an act of imagination. And that, I think, is a key idea that I want you to keep in mind for a little bit here. Because then I'm going to turn this around and talk about the relationship of art. So the 19th century art theorist George Raymond talks about art as distinctively a product of the imagination. So art has, really no other kind of necessary function in the world. It is kind of free from a certain level of instrumentality to be able to kind of act completely within this realm of the imagined. And so if we think about, back to Sachs, about this idea about what art and imagination are, imagination is always employed in the completion of a work of art. When we look at something like this, which is a fresco on the ceiling of a church whose name just slipped my mind. If I was in presenter mode, I would see the name here. But it's in Rome, and it uses all sorts of ways to engage our imagination to bring us into the phenomena of the artwork. For one thing, it's painted on a flat ceiling. It uses trompe-l'oeil to kind of blend the real architectural elements with the fake architectural elements. It's obviously trying to engage us in a narrative about transcendence and about into another realm, so it engages us in our narrative imagination. And it's situated with all of these perspectival tricks that we think we are a part of the story that it's trying to tell. But all it is just little blobs of colored paint that in fact don't have any relationship to anything that it's actually trying to represent. Our brain completes all of those stories for us in our imagination. So even as through time, we've tried to take and instrumentalize our acts of perception and representation. So this etching by Albrecht Dürer of one of his devices he uses to try to quantify the view that he's working with to try to get a more and more accurate representation. So now maybe the artist's imagination is taken a little bit out of the loop in a way that it's not complete. He's not completely making it up, but he's trying to have a relationship with reality that has veracity, instrumental veracity. Now, of course, he also gives us he uses that same methodology to give us this very famous drawing of a rhinoceros, which is easily, a great part of it is fantasy. But it was the predominant way in which Europeans thought what a rhinoceros was for several hundred years. And in part because it uses this kind of representational veracity as a way to kind of give authenticity to what is, in large part, a fantasy. And so over time, there's this relationship between kind of visual representations that have veracity, and we're driven to those things throughout the Renaissance with the invention of lenses and camera obscuras, which are shown that they can show you very clearly what's actually in the world, such as your unicorns. They're excellent tools for capturing this. So again, we kind of are continually slipping between reality and fantasy. And later in the 19th century, we're starting to get into these understandings of these we're creating all these proto-cinematic devices that are explicitly toying with our perception. So here we have the very famous sequence of images by Edward Muybridge, which is trying to, working for Stanford, trying to see does a horse's four legs ever actually leave the ground, and produces this series of images, which you can put into a zoetrope, and now it appears we're watching a horse run. So now we're exploiting the limits of our perception to take what is just a set of static images and now produce this illusion of cinematic motion, and which then is further developed and exploited by people like Edison, who invents the first YouTube videos in about the same time frame. So I would say that art itself is always this collaboration between our senses and our imagination. And so it's easy to say that about art, but of course we can also just expand that a little bit, and it's just our perception of a reality. We see the world through this collaborative relationship And that imagination happens at very small levels and at very large levels. And so here's a cartoon. Excuse me, and I'll maybe read it out loud. Hello, 911, I'm trapped. It's dark and I can't see anything except these two distorted splotches of light. Help. Splotches of light? Your eyeballs? Yeah, I think that's what they are. There's meat everywhere. Ah, so you're a brain. Yes. Yeah, we all are. You're not trapped. Use your body to walk around and experience reality. But everything's just signals in my sensory cortices. How can I be sure they correspond to an external world? I'm sorry, but we can't send a search and rescue team into Plato's cave. And so, of course, this is long the crux of Western philosophy about, what is it about the world that we know and don't know, and how do we know this? And so Plato, thinks that we basically experience the world as if we're these prisoners locked in a cave, and we're watching the world as if it's just shadows cast on a wall. And that the only people who actually really see this particular situation are philosophers. The rest of us are, poor saps, not really knowing what the extent of reality is. So in the Clarke Center, we have these ambitions to, try to understand this phenomenon of imagination, to research specific questions of it. Is there a neuroscience of it? What is this kind of social role of imagination? And then if we understand it, can we start to create positive feedback loops in imagination that can help accelerate its development? Now, all of this came out of work that I'd been doing since the time I met Don 20 years ago at David Brin's house, on new forms of culture that come out of the development of computing. And it got me thinking that what we were really doing in these new vanguard forms of art, we're creating a kind of speculative culture. We were prototyping aspects of our technological, cultural, social condition that to put particular emphasis on certain aspects of them. And so so how could we now take that on very directly to help to develop imagination in individuals and societies to better anticipate the world to come, to look at how our own statements about the future are produced or reified by our acts in the present. And that one thing that I look specifically at is science fiction, and whether or not that over a 100-year history of cultural activity, which is specifically about looking, casting our gaze forward, what does that actually do to influence, to help us think through at a social cultural level the actual outcomes of our present-day actions? And now as we develop these new methods of understanding imagination and cognitive neurosciences, how might these be incorporated into new kinds of cultural experiences? So between those two things, that gives us this basis of the Clarke Center. Then it calls us to pull into play people from a lot of different disciplines. So we have people from all of these areas that are participating in Clarke Center activities, and we have an advisory board drawn from people across campus, from cognitive science, physics, literature, etc. And we also work with a number of science fiction authors, and these are maybe the 5 of them that are very closely involved in the center. And part of the reason is that they're all graduates of UCSD, and so this becomes another key aspect of this, is that UCSD has produced more of today's notable science fiction authors than any other university in the world, and it did that completely by accident. And so now, I guess my hope is that now that we take this on more deliberately, that we don't screw that whole thing up, But they came out of different parts of the university, from computer science, from physics, from literature, and so between these sets of people, we have this broad interdisciplinary conversation that helps us shape our activities around human imagination. And just later tonight, we have film Sleep Dealer that'll be playing down the hall, and a panel tomorrow about Latino and Latina science fiction. But let me now turn back to some of this work that got me to the point of asking those kinds of questions. And so as I said, I have this, I'm an artist. That's what I'm hired to do. That's still what I do. That's still ultimately the outcome that I look for from my work. And so this is just an overview of a bunch of things over time. And I'm going to talk narrowly about one kind of activity that I do. And I'll try to leave some time to give a demo of a project that's now in development. But I do these multimedia environments which try to put into play questions about the nature between our experiences of mediated reality and physical reality. So I'll show you a couple of older pieces, just 1-minute video clips.
Mi Casa is Tu Casa, My House is Your House is a binational networked virtual reality playhouse. Half of it's here in San Diego at the Children's Museum. The other half is in Mexico City at the National Center for the Arts. It has 2 physical spaces in each of these locales. And within these physical spaces, there are a number of things that kids can play with and interact with. Some oversized tools, a giant ball they spin around, a kind of magic mirror. And while they're doing that, they're inputting events into a computer that creates a 3D computer graphic representation of what they're doing. And that 3D computer graphic representation is shared by both physical spaces. Smoke and Mirrors is an artwork commissioned by the Fleet Science Center of San Diego, which allows 2 to 6 visitors at a time to enter into a shared virtual environment. Participants navigate through a series of maze-like environments that explore the shifting ways in which the tobacco industry constructs cultural images in the social environment to maximize usage of its product. Participants attempt to escape the messages that have made tobacco usage desirable and acceptable, even as a growing body of knowledge has increasingly shown the deleterious effects that its consumption has upon the body. Each visitor first has their face 3-dimensionally scanned and affixed to an avatar constructed from an isolated biological system. A network of computers connects each user into the shared environment, and a simple interface allows for control of one's movement through the mazes.
So these projects, so this one is done in the, opened in 1997 when, this was still fairly novel. We had lots of popular cultural speculation about this nature of virtual reality, but at the time it was almost even impossible to get an internet connection in Mexico City. We had to steal it by re-aiming a microwave dish from the university just a little bit so it could capture where this was being shown. And then this is done in the early 2000s as now computer games became the kind of realm in which this kind of experience was taking place. Now to kind of fast forward a number of years from there, I'm going to talk a little more specifically about this Scalable City project, which is really an engine that I've created that generates lots of different kinds of artworks out of it. So there's sets of prints that come out of it. There's videos and movies, machinima, and but primarily what drives it is this interactive museum-based environment. But from it, it's trying to look at this relationship between data, algorithms, and users. And so I have another way in which I could say that formula is the formula of contemporary culture. We have sets of data, we have algorithms we develop, and we have user interactions. And then from that, cultural experience is generated. And so here, I try to make that a very overt condition by taking data scans from the real world, putting them into algorithmic systems that take a familiar object and now start to defamiliarize it, put it in a kind of suggested alternative use. And the users interact with this to articulate it. So for instance, a lot of this came from satellite imagery and looking for patterns and analyzing those patterns and then creating new representations that highlight the particular patterns there. So I make a joke that this is that Carmel Valley development that just got voted down. But so some of these are, these very, kind of classical things that I think both give us a kind of beauty of patterning that computation can readily give us, but also kind of produce an outcome that we might be wary of. So it's set up in these large multimedia environments that are, can be many different screens, or they can be in 3D, or different kinds of setups. And it gets shown at museums all around the world. Just finished a tour of Russia and Switzerland with 3 or 4 museums. And I'll show, well, let me see. I want to check my time. Okay, maybe I'll show this. This is a 4-minute video. So this video, I'll just set it up. What I do is when people play this in the museum, I capture all of their play sessions as data, and then I can go back and do stuff with that data. For instance, I can re-render it. So this is a 3-minute movie re-rendered out of those play sessions that is mastered in 3D 4K, but we won't see it in 3D 4K here. So in the process of creating most of my work up to this point, I'd always been able to count on designing a project. It would take me a couple years to build it, and that by the time I was done, whatever the computer platforms that I could count on would be twice as fast. And as I'm approaching that with this project, realizing, well, Moore's law is still technically in effect, but the way in which you have to program the way computers are taking advantage of Moore's law now has to really change. So in the first part of in the kind of mid 20 noughts, I ran into this problem and ended up finding myself having to dig into how to do parallel programming and multi-core software development, and ended up working with primarily with Intel and IBM on supporting this work, and then with a few other academic partners, we created a National Science Foundation consortium lab on multi-core computing, and so that I ended up becoming a kind of quasi-expert in parallel programming in order to get this artwork to work the way I needed it to work, and it's been a very valuable continuation, because it's also then driven me and the people I work with in my lab to develop a number of kind of innovative approaches to doing that. So for instance, in the Scalable City project, we ended up creating a parallelized physics engine that does orders of magnitude more complex computation than other existing physics simulators, because we did very optimized parallel computing methods. We also have developed methods in which we use large-scale hybrid server systems to be able to serve both that artwork and the other works that you're going to see in a bit. And so here's a little bit of another short video that describes that.
UCSD Center for Hybrid Multicore Productivity Research, we develop new accelerated procedural computing techniques to create a virtual world that is rich with visual complexity and dynamic behaviors. We are in the midst of transforming this into a massive multi-user experience enabled through the development of a new systems design. Hosted at the San Diego Supercomputer Center is an IBM Z10 mainframe, along with an extensible number of hybrid computational accelerator cores. This system computes the asset transformation and dynamics of the virtual world, while maintaining the coherency of tens of thousands of entities for many simultaneous users. This gives us an approach for creating a new type of virtual world experience. One which combines the visual and behavioral complexities of next-generation computer games with the social interactions that virtual worlds have been designed around. Current approaches require you to make trade-offs between these two types of virtual experiences. A key approach is the use of the OpenCL programming framework, which allows our software to be flexibly deployed across a range of computing devices, including the mainframe server, server-based accelerators, and client systems which mix multi-core CPUs with powerful GPUs. This new approach for how virtual worlds are computed will help them to be more engaging cultural experiences and make them more applicable to a wide array of social undertakings in which complex activities are best understood through the interactions of many people.
So obviously a technical description video that is done for the supercomputing conference of a few years back. So now with this work then, this ability to capture all this data of everybody interacting in it and then restaging it, we developed an application called the Virtual World Director, which allows us to kind of then replay and then develop new kinds of scripts within this corpus of people interacting in these data environments. And in the process of doing that, came up with this problem that we have all this data of all these play sessions. Which ones are actually interesting? I'm not going to go back and watch like 1,000 people playing this game. It's too much. And so I noted that if I am watching people play it in a gallery, I can note when there's a good session, and I can note also when someone's playing the environment and they might need a nudge of some sort to get them to go from, like, being totally baffled to having an experience where they go, whoa, or aha. And so, I realized in the process of trying to solve one problem, I was actually stumbling into maybe a much more interesting problem. How do people have, and what about this environment gives them those moments of insight? And could I actually find those in the data? And if not, could I find ways in which I could move them, give them small nudges in the direction of their particular interest that might give them those moments of insight? And so I started coming up with ways of visualizing the experience of people in this environment. And so here, for instance, this is a kind of a typical visualization. It's a heat map of showing how long people are in a particular area. And we can visualize a lot of different dimensions of the data there. But what I really needed to do was come up with a different description of the environment that made sense from the data set. So I came up with a set of semantics about the environment, which were different from what I had designed in the environment. So the environment, as you could see, there's no like real purpose to it. It's not like a video game where I could easily keep a score, or even know that it's better for a person to kind of stand in one place and maybe look around a little, or is it better for a person to try to race around and see if they can get around the world as fast as possible? Either type of experience is perfectly fine, as long as the user is actually being engaged with the experience and getting some kind of insight. So one thing I can do is I can capture all sorts of parameters of different people and overlay them together. So make scatter plots of how long people have spent in a different area, how much people are turning versus going forward, other kinds of things. And then what I could see is that there are certain kinds of tendencies, that there are people who like to be deliberate lookers, and there's people who like to travel quickly. And I could start to see that in the pattern of their activity and maybe try to make the environment respond to fulfill what I'm guessing their desires are, or maybe at times kind of present them an alternative to what they're going after to give them deeper insight. And so here's another visualization of some of those relationships. So the blue dot, this is an overhead view of the blue dot is a person moving through. The pink dot is the virtual camera that their movements control. And based on how fast they move and where they are, that camera it's like an algorithmic string. And so now I'm just going to show a bunch of different users, all normalized at the origin. And what you're seeing in the trace is all of their virtual cameras paths being traced out. And with these different users, what I would find is that there's certain kinds of morphologies of camera space that different kinds of users tend to articulate. That becomes another kind of way to characterize the experience that the different users are having. And so one of the things that I was driven by this is so I would say that the primary parameters of experience are aesthetic. So are there kind of aesthetic criteria that I can assess from the environment? So here's an assessment of a kind of a rough color space analysis. So a user who moves through the environment and sees more ground, or a user who sees more sky. Now, when you can see people kind of creating that visual phenomena as they're going through the environment, but you can't actually ask them to articulate that they're doing that. Now in the data, we can start to see it. We can also start to see it on the kind of complexity of the environment. So here's just taking the environment and doing reducing it to edges. And by reducing it to edges, I have a kind of a simple kind of histogram of the experience in black and white, more edges, more complexity. And we'll see another variation here of another scene that has a lot more complexity. So now here it's a little unfair just looking at a scene by scene, because these people will see lots of different scenes as they play it, but you average those over time. Or you look at similar places with the people are experiencing from different, that are at different times and seeing which visual phenomena they tend to be producing. So that starts to give me a way to kind of like interrogate what these virtual experiences are and provide some mechanism of feeding back into them and developing them in different ways. And so now there's been some other projects this has been applied to. So here's a project that I worked with the Rady School of Management called Verbella. And we created this virtual world in which people from around the world would gather and interact in complex simulations. And these are business simulations that we started with. And so it started with this, these 8 MBA schools. And we created a competition for them where teams of 5 people would be made, no one of which is from the same place. So the first time they're only interacting in this environment. There was a requirement that they all had to speak English in this, and then later on we did other experiments where we didn't have that. And let's see, and I'll play you 2 short videos that describe it.
At Verbella, we aim to improve online education. We develop and deliver virtual world learning platforms that allow for blended learning, including the ability to host lectures, engage in group projects, attend student fairs, play serious games, receive coaching, and compete in simulations. We have started to create and support custom online campuses for universities. The University of California, Irvine has had students utilizing Verbella to join lectures, meet with professors during office hours, and collaborate with fellow students to work on real-world problems. Meanwhile, our development team has developed resources to foster learning and collaboration, as well as tools to research data-driven assessment of leadership and team cohesion. Thank you to the GMAT Met Fund for making it possible. Check out our demo at verbella.com.
I didn't program the dancing at the end. That was, but let me show you a clip from what this looks like in action. It's about a 30-second clip.
Okay, let's look at the other things.
We can do sustainability.
Yes, let's do it, please. Oh my God, finally.
What click do I push?
Yeah, click.
3,
Click it.
2, 1. Trevor, hold your peace.
We're below CO2 level. We didn't drop in the ratings. Revenue still.
Fine, let's go ahead to Mini.
Mini. Oh, Mini.
We are the lowest.
Who is controlling? Yeah, we're very low in price. We can put it up a little bit. Yeah, who's controlling it?
I am.
Suket? Okay. Can I take a look at expansion? Because that seems to be one reason that we couldn't expand. The market is already situated, so we cannot expand. I think no one can expand right now, so it's... Yeah, exactly, so it's fine. Okay, let's keep it like this. Keep it like this.
Guys, we need a decision here. Do we increase the price or not? Hiroshi?
I think we should increase a little bit price.
What are you saying, Jung-won?
I want to keep both. I want to keep price and market.
You don't want to increase the price?
I don't want to any change.
So do we increase the price or not? Jung doesn't want to increase the price. Guys, we have 45 seconds. Decisions.
So what we gave them in this test was they're competing in this simulation. They're running this virtual car company over 3 years. There's a lot of data they have to that they can consult. They have to negotiate their interpersonal dynamic about how they're going to make decisions. There's multiple ways for them to make decisions in the environment. But the environment operations themselves are actually very simple. And we've structured it in a way so that we can tell by just how they utilize space as a way to guide us into what kinds of data they're consulting, whether or not they're making serial decisions or parallel decisions. And so we've then kind of mixed two kinds of modes of analysis. One that utilizes traditional behavioral and organizational psychology methods of surveys and observation. And then we look at the data we gather from the event itself, and see if our analysis and assessment of the data compares to the analysis and assessment of traditional techniques. And so there are some things that, as we're kind of exploring ways in which we do this, that became very obvious. So this is a printout of all these different teams' voice stress patterns. And so one thing we noted was the team that actually had the best actual performance in the environment, and in the assessments showed that people were cooperative, that they had leadership capacity, et cetera, had a particular pattern of voice stress. And teams that were very poor in their performance had a very different pattern. And these are things you might guess. Very dominant speakers. People who the team isn't conversing, but they're kind of one person talking at everybody else, other people not participating. And so from this, now we've developed a number of methodologies of data analysis for these kinds of experiences, and did projects with the SCAG School, Drug Discovery. We have a grant pending with local math teachers to teach a new method of high school math. And these math teachers, we're working with teachers across the San Diego County School District. They don't have time to get together in the real world. So they only have about an hour every afternoon to get together, or 3 times a week to get together, to talk to each other about their methods and to prototype methods of teaching. So they want to use Virbela to do this. So we have ways, so a number of different projects. In January, the initial grant for this came to an end, and now it's been licensed out of the university by a startup. And so now we have a relationship within the university where we're doing research, and a startup who's taking work that's been done and trying to commercialize it. And so now that's data that just looks at behavioral data, analysis that just looks at behavioral data. But we're also trying to look at what can we get by looking at brains themselves. And so we first, plug EEG data into what we're doing in Scalable City and look for correlations there. And as we've done that, we've seen that there are certain kinds of data signatures that we're able to see in the brain, and certain ones that we just forget about it. And you don't. And so then once you figure out what you can get, and is it interesting? Is it actionable? You can see people closing their eyes really easy. So I can hand those out in my lectures, and know when I should tell a joke or something. But there's one here that's really applicable to virtual environments, and it's a sense of space. And so there's 2 primary ways in which we create mental models when we're navigating through space. There's egocentric and allocentric. And so we're working on a new virtual world project. But the first thing we do is characterize, and as we go, we continue to check whether or not people are having this egocentric versus allocentric experience of space. So one in which you move through space and you see yourself in a global coordinate system, one in which you move through space and you see your own coordinate system as the one of importance, and map the world around you. So we have a small experiment that we validated that can show this, and then when we show that and give people to kind of say, well, this is where you think you came from, we'll get 2 different answers, and they'll correlate to different brain patterns that we can see through EEG. And so then we can continue to look at that brain pattern with that particular person as they move through the environment. And we're doing a number of spatial, move them through a number of spatial exercises to see if they continue to keep that allocentric or egocentric brain state, or are there ways we can actually change people's brain states? So we look at that so there's a couple of cognitive signatures that we think are really interesting. And so I think that's the question, is like, these are actually interesting for us to kind of make new forms of culture from. Another thing we're looking at is we're working with a stem cell scientist and to look at the neuronal basis of imagination. And so Alison Moultrie, who's in the School of Medicine here, he can make Neanderthal neurons. And so Neanderthal neurons are interesting because if we look at Neanderthal culture, we see that the earliest artifacts that we have from them are things like these arrowheads, and then the latest artifacts that we have from them are things like these arrowheads. And so over hundreds of thousands of years, their culture remained fairly static from what we can see in the artifact record. But now when we look at modern humans, when we start to see this overlap with the artifactual culture of modern humans, we see the same kind of arrowheads. But over a much shorter time, we move from those to much more useless high technology like Google Glass. Which in a few years, the joke about Google Glass, I think that'll be a done joke when something really extraordinary comes out of that work. But so what we've so here we are. We're very close to Neanderthals in lots of ways. In fact, we only differ from them by just a handful of genes, really, and just a few of those genes are important to trigger neuronal development. So, so we have this experiment that we're getting going now about growing Neanderthal neurons by taking human stem cells and genetic engineering those handful of gene differences to produce these neurons and compare their morphological differences, but more importantly, their functional differences. So setting up an experiment in which we create different kinds of phenomena, and neurons will try to anticipate. They'll fall into patterns of anticipation of this. And so our hypothesis, which we've yet to prove, is that we will see these kind of different functional responses in these different kinds of conditions. So now I want to show you this project. And this is one that maybe what I'll do is I'll demo it. And that's a bit of a risky thing, but I'll try. So this is I would characterize this as an early beta of a project, and this is the only part that works right now. But it's an artificial life environment. So in this environment is a simulation of evolution that is taking place with these little entities. So you see there's these little collections of cubes, red, blue, yellow, sometimes gray. And each of them has a genetic code that describes its function and its metabolism. Now, this is set up so that actually all of you would be able to interact with this environment through your cell phone. So here, I can go in and capture one of these and bring it to my cell phone. And then I can try to look at this little entity and optimize its attributes. So I'll put it in a little rapid evolution genetic manipulator here. So here I'm going to try to take this one and optimize it for changing direction quickly, and that was a terrible one, so it didn't have the underlying characteristics. But I'll come in here and grab another one, maybe this one. And this one's moving nicely. So I can come in here and try to make this a more robust entity through genetic manipulation. And all I'm really doing is setting a new fitness function here on my device, saying, I want you to move faster, or be smarter, or see further, or see more things. And then I can put it back in this environment. And then it will see over time. So then there's so I just made this one, it's called Spark Puctified. So it takes its naming out of a lexicon. And over time I could see whether or not this becomes, has robustness in this environment. Does it take over? Does it die out? Does it go away? And so if a bunch of people are playing this, we could see this happen from everybody's input into this environment over time. Now, let me, another thing here. So now what's also happening here is what's taking place inside has an effect on this outer environment that it's a part of. And so what this project really sets up is multiple levels of evolution where you have this symbiotic relationship at these different scales. So here we're seeing the actual, just the initial scale of this soup inside of this entity. But as we go on and develop this further, what will happen is this outer entity is a part of another environment at a higher evolutionary scale. And we'll see if that works here. Oh, and I think that's in the other version. Oh, we'll see. So let's see if this next environment loads. Yeah, okay. So it moves from this lower level description that is more the chemistry and low level biology to then when we start to get to higher levels of representation that are more organism based. And again here, it's a similar thing where we're able to go in and capture these entities and do, again, similar kinds of genetic manipulations of them that then come back in and we see about their level of robustness. So it moves from these different kind of scales of ideas about how evolution is a schema of development, from low-level kind of model of it to biological systems to then things that start to beg the questions about cultural impacts of evolution. And this is by far the least articulated at this point. This is more just a sketch of some of the aspects that are going to be a part of it with different kinds of avatar representations and other things. So here I'm trying to give a certain kind of agency into the underlying mechanics of the system itself and utilize this scheme of evolution to create this kind of visceral connection to this idea about what evolution is as a process, its kind of power, its unexpectedness, and that it has this relationship not only to how we understand the biological world, but how we start to understand the cultural world that we're a part of. So let me just finish with a couple of things. So one of the things we do at the Clarke Center is we try to bring these conversations to light in a number of different ways by doing these kind of research and creative projects, by doing different kinds of educational things. So we run seminars with the Kavli Institute here on creativity and imagination. We're part of helping to develop and design a new major in speculative design. We run a summer workshop in science fiction, the Clarion Science Fiction Writers Workshop. People like, years ago, people like Bruce Sterling came out of this, and Kim Stanley Robinson and others. We have an annual symposium we do with the Smithsonian that we just completed a version of this a few weeks ago. This is from the first version. You can recognize one of the people that you might sometimes find hanging out here. Albert Lin was a part of it last year. And we take on certain kinds of subjects that we think are, kind of stretching these ideas. So if one was a symposium on Starship Century. If we built a starship, if we took a 100-year-long project to create a starship, why, how, what would it end up being? And bring together people like Freeman Dyson and Paul Davies and Neil Stephenson and people running SpaceX and NASA to talk about this. So we have this series of lectures that we try to take these kind of topics that require this kind of interdisciplinary interrogation from a new kind of our science of understanding it, the kind of cultural and social impact that different kinds of questions have. So whether it's planetary defense or the discovery of the first exoplanets and now the several thousand exoplanets, just leading up to having billions and billions of exoplanets that we all know are out there. Looking at the kind of cognitive aspects of math, that math has, that different kind of cultures have different relationships to concepts of space and time, and it gives them different ideas about what different mathematical concepts. To things about the multiverse or things about the digital production of architectural environments. That one's maybe too complicated to go on. And then we have this science fiction film series. And so we'll bring people that have a relationship to these notable science fiction films. So for instance, this is Jill Tarter, who the Jodie Foster character is based on in Contact. Gattaca, where we talk about Larry Goldstein, who is the director of the Sanford Stem Cell Research Center. I'm sure it has a more specific name than that, but and a sociologist to talk about the issues of genetics and identity. We did the Andromeda strain at the peak of the Ebola epidemics, just to add some fuel to the fire, And I don't want to talk about that now. Oh, so then we have these ways in which we study and interrogate imagination. I thought I had another couple of slides. My favorite slide, I left my favorite slide. Oh, there it is. I skipped over it. 2001, of course we do 2001. And we brought both Hal and Dave to 2001. And large-scale project that I'm not going to show because we're definitely over time now. But we did this workshop with Stan Robinson and Marina Abramovich. It's resulted in an installation at the Venice Biennale right now, and a film project and a podcast. So again, it kind of produces multiple things out of this. And maybe I'll just start I'll just show you 10 seconds of the film.
Space is not empty.
We are flying between the stars.
Our voyage will take centuries.
All our names never name. Possibly this is why we have come to this pretty pass and now lie dreaming together between the stars.
So anyway, that's all you'll get to see of that. So that's too much information, as they say. But I'll take any questions. Yeah.
So you seem to have a number of projects going on. I'm just curious if you use your own imagination to manage projects.
Probably not well enough, I have to say. But I try to look at how, some of these things, and I didn't really go into these, but there's other things that we're trying to do where we figure out how to take imagination sessions and make them more actionable and subjects of interrogation and further development. So I'm interested in how my own imagination itself might be furthered and how other people's imagination might be furthered. But the management part is, I don't know. I certainly probably should spend more imagination cycles on that. But those imagination cycles are precious. You don't want to spend them on administration. You want to spend them on creation of good stuff.
I have a question. I just wanted to, when you talked about the evolution piece, assembly, you said something at the beginning I wanted to check with you. You said that you're defining the units by a functionality and metabolic.
Yeah, so each little assembly, so there's a genetic, the assemblies have a genetic code. Each of those little cubes you can think of as a cell that carries a copy of the genetic code. And what the genetic code specifies is things about the function of the assembly based on its morphology. It talks about how it can connect to other cells, and if it's connected in other cells certain ways, then certain kinds of functions express themselves. And then all of those functions, the attributes of each of those functions is expressed. And I've tried to come up with what, to me, is the most reductive form that I can. So I have like 4 kinds of cells that end up emerging. So there's a sense cell that also brings input, energy, nourishment from the environment. There's a cognition cell that takes whatever those sense cells are getting, and they produce an output signal. The cognition cell takes whatever output signals are connected to it, and it integrates them based on whatever parameters it comes up with. And then there's an action cell, which gives an impulse of a certain force in a certain direction at a certain frequency to the entity it's connected to. And it has its parameters. And then all of that, then the cognition and they all have certain kind of metabolic rates that they need a certain level of energy. And so that gives the organism itself a metabolism.
So I was just curious about how you think about the functionality, because functionality is kind of a slippery kind of area to try to capture, right? And it can emerge and it can change. So I just wanted to know how much you kind of try to have almost like predetermined functions that you approach. But it sounds like from your description that they're much more operational kind of descriptions, right?
Yeah. I mean, that's what I described as exactly what's encoded in them. And then 2 of them, I guess I probably didn't show this very clearly, but in the soup environment, they reproduce by mating. So when they're also looking for food, they're also looking to mate, and there's certain characteristics that allow them to mate. There's a level of kind of organism complexity that is within a ballpark of similarity that allows them to mate. They produce an offspring that combines traits from both with a bit of mutation rate that we can dial up or dial down. And but sometimes you'll get them where there was cognition nodes in the parents, and then the offspring don't have any cognition nodes, which a metaphor of parenting, I guess. Or you think they have more cognition nodes than they really have is another metaphor of parenting. So I try to keep that very reductive. And then as we scale up, I try to have the next level of environmental complexity still at the organism level described by still a kind of that simple level of operational rules. And then see if the thing gets this kind of larger scale emergent complexity.
And just poised with the idea on the examples you gave us. You started with the cubes, and then you developed on the second part, like with a more organic shape.
Yeah.
Is there something that entices you, or the reason that you start with cubes, something geometric instead of organic?
Well, and what you'll see is, as when I actually end up finishing that second level, I think it'll have you'll see a closer affinity. Now they're very far apart from each other aesthetically, but they'll end up becoming closer together. Well, I wanted the cubes because I wanted it to read like it's a model. You know, this is a schematic description of, you know, that we use to, and it's an abstraction of something that we think is an operational model of the world. But you know, so I want to kind of keep it in that mode of you consider it as this model, and then now consider it as this model gets applied to these higher and higher levels of complexity that start to then kind of suggest themselves as being either organic or higher level cultural ideas.
Or any other.
Yeah.
So are there any research questions for us, either as scientists or designers, that you'd encourage us to be thinking about for the future of the study of imagination?
Well, for scientists and designers, well, one of the things that we're trying to figure out how to ask, and we've got some ideas, but you know, I don't think they're quite getting it yet. But this, you know, this way in which we can kind of trace the influence and impact of ideas that are, you know, that are kind of speculative or forecasting or, you know, meant to kind of cause you to anticipate, and what the impact those ideas have on the world that actually ends up coming about. And so you know, so we're trying to look at ways in which maybe different kinds of literature have certain kinds of themes at different times. So if we look back at the kind of history of science fiction literature, you know, what are the, you know, dozen, 100 or so themes that kind of appeared in science fiction literature of 1952, and can we come up with is there a taxonomy of those? How do those themes relate to the kind of worlds that ended up coming? What are the certain kind of attitudes that come around those kinds of themes about, you know, their dystopian impacts or their utopian ones? And it's a level different than saying, well, they said flying cars, you know, we still don't have flying cars, you know. So the most interesting thing about science fiction isn't the kind of first order things that they describe, but it's always those second, third, and fourth order effects that these things end up talking about. And so that discerning those is, you know, part of the trick.
So the flip side to that is the failure of imagination with real science, where you have things that all sorts of unanticipated effects from DDT, and now we're looking at GMOs. What should we be looking wider at that we haven't, and how does that fail?
Yeah, so there's this, you know, so I think, you know, so much about the Clarke Center is this kind of like very utopian kind of thing, you know, that you know, another way that I described this early on is that I think there are these different attitudes about the future that come out of science and engineering that are different than the attitudes about the future that come out of arts and humanities. And so I'd say that, and maybe I'll just pick on the humanities and not the arts right now, but I'd say the humanities are inherently skeptical about the future and future developments. And science and technology are inherently naively optimistic about their outcomes of their work. And, you know, so what is it about the kind of historical analysis basis of the humanities, of being able to look back on things and interrogate and uncover, that is, you know, really, really a powerful methodology of understanding, and understanding kind of the unanticipated, understanding the multiple, understanding the hybrid, that isn't a part of thinking about the developments of futures that comes out of scientific and technological work. That often things are cast in these fairly simple, you know, notions of outcomes that, you know, ubiquitous vision is inherently a good thing. You know, we all want that, or you know, or omniscience, you know, of our information systems is just inherently a good thing. Now, maybe it's a good thing, but maybe there's other ways to think about, you know, knowledge or you know, what we know about what and what we know about who that might actually shift the direction about how technological research and scientific questions are asked. So there is a hope that there's this kind of level of discourse that can happen between these fields where we can bring this kind of analytical, critical smarts of the humanities with the kind of inventive thrust of science and technology. In part, that's why we stage these conversations around these kind of large issues that try to put those different perspectives into play with each other.
Thank you.
Thanks, Don.